Welcome to the Deep Dive. We're here to cut through the noise, get straight to the insights. Today, our mission is tackling a common data challenge: flattening complex JSON in PySpark. We'll look at a neat, recursive way to do it. You know, those multi-layered JSON files, they can be a real headache.
Oh, absolutely. It's fascinating, actually, just how often this specific problem crops up. Doesn't matter what domain you're in. If you work with data, you've likely hit this. Nested structures are, well, they're a frequent hurdle.
Totally. So the core issue we're diving into is taking that really nested JSON, you know, the kind with both arrays, array-type fields, and nested objects, the struct-type stuff, and turning it into a nice, flat PySpark data frame.
Right, and the solution we're discussing, it's quite elegant. It's this recursive function, flatten JSON. The really clever part is how it adapts. You don't need to manually write code for every single level. Think about how messy that gets if your schema changes, right? This function just handles it. Any level of nesting.
Okay, any level. So are we talking like 10, 20 layers deep, and the code just works?
Pretty much, yeah. That's the whole point of the recursion.
How does it actually do that? Walk me through the logic a bit.
Sure. So the function first looks at the data frame schema. It finds the complex fields. If it sees an array type, it uses explode outer.
Explode outer. Why outer?
Good question. Explode outer is key, because if you have an empty array, it keeps the row, but with null values for the exploded columns.
Yeah.
Regular explode would just drop that row entirely.
Right. Prevents data loss. Makes sense. And the nested objects, the struct type fields?
For those, it expands them out. It creates new columns for each field inside the struct. And it uses a smart naming convention, like a parent field dot child field.
Dot notation.
Exactly. That keeps the schema organized, and importantly, it stops column names from clashing, especially when you go multiple layers deep.
Okay, that sounds systematic. But the recursion part, how does that loop eliminate the need for, manually unwrapping everything yourself? That's the magic.
Yeah, precisely. Here's where it gets really interesting. The function is the loop. After it does a pass exploding arrays, expanding structs, it looks at the resulting data frame again. It checks. Are there still any complex types left? If yes, it just calls itself again on the new data frame structure. It repeats this flatten and check cycle.
I see. So it just keeps going.
Until the check finds no more array type or struct type fields. Then it stops and returns the completely flat data frame.
Wow. Okay. That does sound powerful. Almost like too easy.
Are there any catches, performance issues on really huge data sets maybe?
That's a fair question. Performance can be a factor with, truly massive data and extreme nesting. The function's pretty optimized, but like anything in Spark, you'd want to glance at the execution plan for very large-scale stuff. But honestly, for the vast majority of use cases, it's remarkably efficient. Okay, got it. So let's bring it back to the listener. What's the real practical benefit for you? It means taking that messy, deeply nested data and getting a clean, flat table ready for analysis. Without all that tedious manual work, it's basically a shortcut, right? Straight to usable data.
Exactly. You save a ton of time and potential errors. And it's worth mentioning this approach builds on some great work. It was inspired by Viral Patel's work on JSON flattening in PySpark. But this version adds that recursive logic, plus some optimizations and better error handling, making it really robust for more situations.
So summing up then, this deep dive showed how a clever recursive function in PySpark can systematically flatten even really tough JSON structures. It offers a robust, dynamic, and pretty much effortless solution.
Yeah, and if you zoom out a bit, look at the bigger picture. It really highlights the power of recursion itself, right? Taking a complex problem and breaking it down into a simple, repeatable step. It turns something potentially overwhelming into a manageable, automated process.
That's a great point. Which leads us to a final thought for you to consider. Think about where else in your work, or even just your interests, you see repeating patterns within complex problems. Could applying a simple, iterative process like this recursion help flatten out other kinds of nested headaches? What else could be unraveled this way?